Okay, Carol is asked to test for question 10 whether a coin is biased in favor of heads using a 5% level of significance. She toasts the coin 100 times and obtain a 57 hits. Carry a hypothesis test. Test your known and alternative hypothesis query. Okay, so for this question 10, the question never mentioned about the distributions, but from the question, uh, you note that you have the finite n and you have a heads or tails. Okay, so two choice only. Okay, so this question actually originally is a binomial. It's a binomial. Okay, so if binomial, try to consider to use back the binomial approach to do the question first. Okay, so let's see. If you ask you to do the hypothesis test, okay, so for binomial you will use the p for to set the hypothesis. Okay, original hypothesis this is equal to 0.5. Okay, and this is h0, h1 p is biased in favor of hits, so p will be larger than 0.5. Okay, bias in favor of hits, and this is the original binomial distributions 0.5. Okay, the parameter, and question say carry out the test, you have obtained 57. Okay, larger. So if you without the doing any approximation, what should you find? You should find something like that. Because the question say larger, so you test the upper side. So in this situation, px larger than 57, you are not able to find, not say not able to find, actually you want to find also can, you will need to find from this one have equal. Okay, you will need to find from 57 until 100. Alright, so many steps. Alright, so for in this situation, normally or in the previous paper 5 you still remember, step 1, you will go and check MP is what, NQ is what. Okay, so for this case, MP is 100 times 0.5, 50. NQ also equal to 50. Right, both of them are larger than 5. Okay, so you can do the normal distribution. So first thing, using this approach first. Okay, and so once you have this, you can form the normal distribution for these cases. This case, and you have 50. NBQ is equal to 25. Right, so you have a distribution in this way. So now if you want to find the, if you want to convert this discrete data to a continuous data, so what should you do? So this one will be a little bit different to the CLT. So every time, if you possible using this way first, okay, if this one is not fulfill the question, then if the question asks you to use CLT, then use CLT. Right? If the question did not ask you to use CLT at the first place, use the basic solution first. Okay, so now you need to find what p, just now p z, px larger equal to 57. right? Px larger equal to 67. So if I want to convert this one to Z, what should I do? So the Z will be equal to larger equal to 57, so 56.5 minus 50 over 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 the square root of MPQ, right? So square root of 25. Okay, so in this part we will consider the continuity correction for this part. Please remember that. So once you have this, you should get your calculation, you should get Z equal to 1.3. Okay, so and this one you will test at the upper part larger and 5% significant level. 5% significant level upper part, you will have 1.645. So you can say that this one is less than 1.645. Okay, in this situation, less than 1.645 mean so your Z will be reject H1 right, in favor of H0. So in this situation, what you can say? So the claims that you can say the claims that coil is biased in favor of heads is not supported. Okay, you can say a coil is biased in favor of heads is not supported. Okay, so this one for question 10. Okay, now we proceed to question 11. Okay, question 11. A manufacturer claims that a particular blend of a seeds has a germination rate of 90%. To test this claim, 150 random selected seeds are planted. Okay, it is noted that 124 germinate. Okay, use a suitable approximation to test at 1% significant level whether the manufacturer is overstating the germination rate of the seeds. Okay, so in this situation, you need to verify first, is it under binomial or not? Okay, so for this case, you have a germination rate, okay, 10%, 90%. So you have yes or no only, germinated or not germinated. Okay, so you have two choice only, and you have a finite number 150 finite number, right? So you can form a binomial distribution for this case. So in this question, we will set the hypothesis first. Sending P equal to 0.9, the original one, and H1 will be P. The germination test whether the overstating. So is it lesser or not? If overstating means lesser, lesser. Right. So then you set your parameter. Once you set a parameter, and question is asking you to find what? Okay, it's not that 124 is germinate. Okay, so 124 mean the question say test the lower part. Okay, so you need to find, actually what you need to find is find px smaller than 124. Okay, smaller than 124. Okay, if you want to find the probability, this smaller may refer to the alternative statement. If the alternative statement smaller, mean you use smaller. Okay, so if you want to find this answer smaller than 124, you need to have at least 26 steps. Okay, in order to find the answer. So it's not suitable for you to find step by step. So you need to consider do the approximation. So MP is equal to 150 times 0.9. So you have 135 larger than 5. NQ equal to 150 times 0.1. So it's 50 more than 5 also. So means you can use approximation, right? So now you can find the MPQ, okay, in order to find the answer. So you may able to find the normal distribution, 135 and 13.5. So this is your parameter. Okay, so once you have this parameter, you can start to find the Px smaller equal to 124. Okay, so smaller equal to 124 means if you convert this one to the z value will be equal to 124.5 minus 135, okay, over square root of 13.5 square root of 13.5, okay, at the below square root of 13.5. So once you have this, you can do the further calculation. So you have z equal to negative 2.857, and the question is asking you to test 1% significant level at the lower side. So 1% significant level, if you refer to the table, will be 0.99. So you have a negative 2.326. So this one is smaller than 2.326. Right? So once you have this, okay, once you have this, you can say reject H0 in favor of H1. Okay, this is a general statement. And once you have a general statement, then you can do the final conclusion. Okay, so you can say at the 1% significant level, so the manufacturer is overstating the germination rate. Okay, so you can say the manufacturer is overstating the germination rate. Okay, or you say the claims of the claims that the manufacturer is overstating the germination rate of the seeds is supported. You can say like that also, no issue. So this one for question 11. Okay. Right, so we go for question 12. Question 12. When cars arrive at a certain junction, okay, they can turn either right or left. Part of the student of route usage involve deciding between the following alternative. Cars are equally likely to turn right or left, car are more likely turn right than left. Okay, a hypothesis test is carried out at 2% of significant level, pass a sample of 40 cars. Okay, state the suitable node and alternative hypothesis. Okay, B, find the critical region. So for this question, you need to state the hypothesis first. So we start first. A, 0.5, right, equal, and H1 will be P larger than 0.5. Okay, so I will use the more likely to turn right than left. So there are the student that can use another side. Okay, so if you say you can put P smaller than 0.5, if you use the left side as a benchmark, but normally if you follow the standards, I will use the right hand side for benchmark. But if the student want to change another side, no issue, right? You should get the same answer. Okay, so this is the things. So state this is A. So for B, find the critical region. So you state the parameter first. Okay, and so this question did not mention what. Right, so we check first. Okay, but this is not your parcel. Normally in the real situation, right, they will give you certain hints for you to find. Right, uh, so question is ask you to find the critical region. So the critical region mean what? The region that you will reject. H not, right? Okay, so now we see if you use the approximation approach, what's happen. Okay, so for this case, let's say MP is equal to 40 times 0.5. So it's 20 larger than 5. NQ also 40 times 0.5. So it's 20 also larger than 5. So once you have this conformed, then you can actually form a normal distribution. Okay, once you have this, you may need to find the critical region. Okay, so this critical region will be the, so on the top you want to test larger side, so mean P X larger than the critical values is smaller than 0.02, right? Okay, so in this situation you can direct put this one as a as in this way, Px larger. So you have you can technically put as in the Z way. Okay, larger than or larger equal to C, means your C will be minus 0.5. Right? Okay, C minus 0.5. Then minus 20 over square root of 10. Okay, so for this question you can put equal to 0.02 actually. Okay, you may put equal to 0.02. So depends on how you're going to calculate the values. Okay, so now we proceed. First. Okay, so if I direct put as a, I get a Z value out. Okay, and this one I can put equal. So you can refer to the diagram, see what happened. Okay, so if smaller than 0.02, if you refer back to the booklet, the formula booklet, if you find back 0.02, another side will be 0.98. If 0.98 probability, okay, normal distribution will be equal to 0.98 probability. 0.98. Okay, so you will get 2.05, 2.055, 2.055. Okay, you can do it this way. Okay, so then you can proceed to calculate this. You will simplify this. You will get the C something between will be about 226.998. Okay, but don't forget your critical value is a discrete data. So if this one you need to round off. Once you round off, you will get 27. Okay, so this is a critical value. Okay, so at the boundary there. So your critical region will be x larger equal to 27. So this is your critical region. Okay, so 27 is a critical value. X larger than equal to 27 will be the critical region. So this one for part B. Okay, for part 2, for the test described in the part 1, calculate the probability of type 2 error when in fact 80% of the car arrive in the junction turn right. Okay, so what happened is, so now your P change, your P changed to 0.8 already. The original P is 0.5. Now your P changed to 0.8. Okay, you see what happened for part 2. So for part 2, when P equal to 0.8, so your NP is equal to 40 times 0.8, 32. Okay, larger than 5. NQ will be 40 times 0.2. Okay, will be equal to 8, larger than 5 also. So now you can calculate the NPQ. So you should get the normal distributed as 32 and 6.4. Okay, so now you can try to calculate the probability of type 2 error. Okay, the probability of type 2 error will be the probability of you accept, right, hash node. Remember that, accept hash node. Okay, when you will accept hash node, okay, so now we set the critical region when x larger equal to 27. Okay, we will reject hash node, right? So if you want to accept hash node, will be the probability of x smaller than 27. Okay, opposite side. So smaller than 27, we will accept hash node. Okay, so if you want to find this probability, will be Pz smaller than 26.5 minus 32. Okay, over square root of 6.4. Okay, so when you do further calculation, you will get Pz smaller than negative 2.174 and 1 minus 0.9852 and is equal to 0.0148. Okay, So this is the probability of type 2 error. And the question you're asking what the probability of type 2 error? Yeah. So this is the answer. So you may simplify three significant figure, and this is for the part 2, right? Okay. So next part we will move to uh, hypothesis test for the poison.